This is 4.2, multiplying and dividing rational expressions. So you have your essential question that you're going to answer at the end. How do you multiply and divide rational expressions? Okay. So the rules for multiplying rational expressions are the same as the rules for multiplying fractions. You multiply the numerators and you multiply the denominators. So they have a little thing, look, a over b times c over d is a times c over b times d. You just multiply across. And that is the same thing as if you remember in all of your other math classes. When you multiplied 3/4 times 2/3, you just multiply it across. You get 6/12, which, by the way, you always have to simplify. And that's still true for this, except now to simplify, it's a little harder because when you break into factors, you actually have to factor it instead of just saying what factors they have in common. Okay, one thing I want to have you realize is dividing is the same as well. We'll talk about this in a little bit. But when you divide with fractions, you have to remember keep, flip, change. So you keep the first, flip the second fraction, change it to multiply. So I get 21 over 24, which, what do they have in common? Well, they have 3 in common, so 7/8. That is what you learned previously in math classes. Now we're doing it with polynomials is the only difference. Okay, so some polynomials are single terms like these, and these are kind of the easiest ones. You can simplify first, you can simplify second. I would recommend simplifying first if you can. In this case, nothing actually simplifies. So it's a really easy one, we just multiply across. So in this case, we have 6 times 3, which is 18, r squared times r squared, which is r to the 4th, right? 2 r's and 2 more r's makes 4 r's total. Kind of count, that's kind of what the exponents do, is count how many there are. 5 times 7 is 35, s cubed times s is s to the 4th. And they have nothing in common, so that's it, we're done. Easiest one, didn't simplify, single terms, little too easy if you ask me. So let's make it a little more complicated. So we could multiply across first, but like I said, we want to simplify it first. It makes life so much easier if you simplify first. And anything on top can simplify with anything on bottom, because that's what, right? Multiply. We just multiply across the top and across the bottom. So anything on the top of any of the fractions can simplify with anything on the bottom of any of the fractions. Okay, so this one has a Gcf Factoring. And remember, pluses and minuses are like glue. You can only simplify if the whole thing is the same. So c minus 1 is the same, simplified. So I end up with just a 4 left on the top, 2 times 3 on the bottom. Oh, I missed one. I should have simplified the 4 and the 2, but I can do it now. So notice you can simplify at the end as well. But if you simplify as you go, it makes life a lot easier. So 2/3, that one simplifies to just 2/3. Okay? So there are 2 methods for simplifying rational expressions. You can simplify first and then multiply the remaining factors. You can also multiply first, then simplify, just like I said. Using either method will result in the same answer. Number 3. Okay. When you see something with a fraction times something that's not a fraction, make the thing that's not a fraction by putting it over 1. This stuff is on the top. It's always on the top. So a 1 is on the bottom. Okay, that's important to recognize. So we need 2 factors. So this one factors to x plus 1, x plus 1. You could combine them, which if we have stuff left, we will. The bottom is a difference of squares, x plus 1, x minus 1. Times, this one is just a 1, so I'm going to keep that. This one simplifies, or factors to x plus 3, x minus 1. And now, anything on the top can simplify with anything on the bottom. So x plus 1 right there and right there, those 2 are gone. X minus 1 right there and right there, those are gone. So what am I left with? Well, I have an x plus 1 times an x plus 3 on the top, over 1 on the bottom. That's the only thing left. And recognized if I divide by 1, I can write it just by itself. as long as the 1 is on the bottom. If the 1 is on the top, remember anything on the bottom needs to stay on the bottom. Unless it's just a 1, that's when we can simplify. And notice I do not multiply out. Do not write in standard form. If you start writing things in standard form as your answer, that is how I know you used something else, because we never do that in this class, and you should never do that in this class, okay? So do not multiply these out in the end. This is your final answer. It is simplified. We're done. If you start multiplying out, I know it's photo math, because that's what they do. Okay, example 4. So simplify c minus 4 over 5 times, and this one we have 45. And I want to try and match the c minus 4, so I'm going to take out a negative 4 GCF. That negative changes the sign, so this one becomes positive c. This one becomes negative 4. And notice, look, simplifies. Oh, the 5 and the 45. I'm going to simplify ahead of time now. The 45 turns into a 9, and so this first fraction completely simplifies. All I'm left with is 9 divided by a negative 4, which a lot of people ask, well, what happens to that negative? You can leave it like that. It can be on the bottom, it can be on the top, or it can be on the front. It does not matter. As long as there's one negative, it just means it's a negative fraction. Okay? There's 2 negatives, those simplify. Negative divided by a negative is a positive, so make sure you simplify. But if it's just one negative, you can write it anywhere. All right, whenever you're dividing rational expressions, remember KFC. We've got good chicken, and also keep, flip, change. Keep the first fraction, flip the second fraction, change the sign to multiplication. Okay, so we always do that first. So really, every division problem, we just turn into a multiplication problem. So x plus 4 over 3x plus 12. Notice I'm not even factoring anything yet. And keep the first, change it to multiply, flip the second. Sorry, that was the wrong order. Keep the first, flip the second, change it to multiply. So I just, whatever was on the bottom, I write on top. Whatever was on the top, I write on the bottom of the fraction now. Now we simplify. So on the top, I have x plus 4. Remember, the plus is like glue. Can't simplify unless it's the exact same. So take out a 3 GCF. And the other fraction doesn't simplify at all. So the x plus 4s, those are the exact same factors. The 3 and the 6 can simplify, because that doesn't have a plus, that has a multiply. So they're not glued together. Okay. And so what am I left with? 2x squared on the top, 1 on the bottom. So my answer is 2x squared. Okay. So let's get into a little more complicated ones. Nice thing with division, we change it to multiply. First thing, don't even do anything else. You can, but a lot of people start making mistakes as soon as they start doing 2 things at once. So just keep, flip, change. Do that first. Okay, now simplify everything. So that first one is x plus 4, x plus 2 when I factor it. Notice I'm going quite quickly through the factoring part. I'm not showing all of my work through the factoring part, because you should be at this point with factoring. We have factored a lot of things. You should be at the point where you can just look at it, especially these simple ones, and write it out. If you're not, you need to practice more. All right, so the x plus 4 simplify. That one's easy. The x plus 2, a lot of people want to simplify all of them. Remember, we only have 1 on the bottom. I can only simplify 1 of them. It doesn't matter which one. Choose one. That's the only one that simplifies. And in the end, we end up with 2x plus 2 on the top and an x minus 1 by itself on the bottom. And there we have it. The x's do not simplify. They are stuck together with those numbers because remember, pluses and minuses are like glue. They stick those things together, and we can only simplify the whole thing or none of it. Also, don't multiply out. There's no point. Don't need to do it. It's an extra step that is unnecessary. Okay, example 7, divide. So first thing, rewrite. Keep, flip, change. KFC. Keep, flip, change. So I can rewrite this as 1 plus n, 1 minus n. On the bottom, I get n. Up here, I factor out an n, and I get n minus 4. And over here, I get n minus 1. Okay, so this is interesting. These look like they're going to simplify, but they are not exactly the same yet. Okay, so we have a special skill that we've been using for a long time now that you need to know how to do. And that is take this one and factor out a -1 GCF. Oh, also don't forget that you can rewrite these. This one is kind of confusing. So I can actually rewrite it as n plus 1, right? Addition, so I can change the order. 2 plus 3 is the same as 3 plus 2. Addition is nice. The other one, however, I have to take out, since it's subtraction, I have to take a -1, and that's when it switches. All over n times n minus 4 over n minus 1. Now the n minus 1 simplify. The n's also simplify. Should have seen that earlier. Okay, so what am I left with? Well, on the top I have a -1, an n plus 1, and an n minus 4. On the bottom, all I have is 1. Everything simplified, so remember you're just left with a 1 on the bottom. So -1, n plus 1, n minus 4. Do not multiply it out. Leave it in factored form. Done. Okay, example 8. We have, what looks to be super confusing, but remember, a fraction fractions represent division, right? If I had a fraction 1/4, that means 1 divided by 4. So this is 1 over x plus 4. Technically that's division, but we're dealing with fractions right now. So I'm going to leave that first fraction, divided by, so instead of this big line, I'm going to put divided by 2x squared over 2x plus 8. That is exactly what we've been doing. Keep the first, flip the second, change the multiply. KFC. Okay, now I factor. First one doesn't factor. 1 over x plus 4 times 2 GCF. And that's it. Okay, the x plus 4's simplify. They're exactly the same. Remember, these are not stuck together with a plus or minus, so I can simplify. And so I'm left with a 1 on top and an x squared on the bottom, and that is it. We're done. 1 over x squared. And last one. Seems a little crazy once again, and it is. Okay, so we have z squared minus 4 over z squared minus 2z plus 1. That is raised, it says a to the -2 power. And then b, which is z squared minus 3z minus 10 over z squared minus 1. That is raised to the +2 power. So, you need to know what negative exponents do. Okay, this is a reminder. We're going to deal with these a lot throughout this unit and the next unit, first unit of next semester. Negative exponents create a flip. They do not make things negative, they create a flip. So I can rewrite this when I flip it with a positive exponent. And then the other one stays the same because it is already positive. Okay, so all we have to do now is simplify each thing. So the first one simplifies to z minus 1 over z plus 2, z minus 2, all of that squared. The other one is z minus 5, z plus 2 squared over z z plus 1, z minus 1, all of that squared. Not just that one squared, all of it is squared. Okay? So the squareds just mean each thing inside is just happens twice. So z minus 1 squared, z minus 1 squared, z plus 2 squared, z minus 2 squared, times z minus 5 squared, z plus 2 squared, over z plus 1 squared, z minus 1 squared. Okay, and then we look, anything on the top that matches simplifies. So one of those simplifies, one of these simplifies, and that's it. So what am I left with? I have a z minus 1 squared, a z minus 5 squared, that's on top, over z minus 2 squared, z plus 1 squared. Don't multiply out. Just leave it in factored form. And there we have it. So that's by far the most complicated problem. You'll see. Okay. So you have your 3-sentence summary to write.